All right, so in part 1 of our video, this is where we stopped. We made a table using at least 5 values for x, we plotted the ordered pairs, and we drew the 3 parabolas. And we noticed that the x squared parabola right here is called the parent function. That's just the basic x squared function. By adding numbers to it, we keep the same shape, but we can stretch it, we can shrink it, we can flip it, we can slide it. So let's see what happens. By multiplying that function by 2, what we actually do is not make it bigger by 2, which logically you would think multiplication, that's going to make it grow. What it's actually going to do is make it steeper. It's going to make that slope steeper, which is going to look like it shrinks or makes the parabola more narrow. By multiplying it by a negative 1/2, what the negative does is flip it downward over the x-axis. And the fact that it's by 1/2 actually makes our parabola wider. It stretches it, it makes the slope not as steep. So these numbers here are really affecting the slope of our quadratic function. By multiplying it by a number, it makes the slope steeper and our parabola narrows. By multiplying it by something less than 1, it makes our slope wider and it makes our slope less steep, which makes the parabola appear wider. We can see that x equals 0 is the axis of symmetry for all 3 parabolas. So if we were to draw a dotted line right there, you can see that that is the axis of symmetry. For our black f of x and our blue g of x, they both have a minimum point at 0, and our red h of x has a maximum point at 0. For all 3 of those, 0, 0 is the vertex. For 2, it's the minimum point, and for 1, it's the maximum point, but it is the vertex for all 3. The range of f of x and g of x, remember range is our y values. Okay, so all possible y values for f of x and g of x are greater than the vertex. Our vertex was at 0, so y must be greater than or equal to 0. For our h of x, since it's going downward and it has a maximum point, the range is less than the vertex. So our range is y is less than or equal to 0. Remember that for all quadratic functions, our domain is going to be the set of all real numbers. All real numbers, because the parabolas will keep spreading to the left and to the right for all infinity, so all values of x are possibilities. Adding a constant, c, to the graph f of x equals ax squared translates the graph vertically. Remember, translates, hopefully you remember that from geometry, just means it slides. So the graph retains its same shape, it just moves it to the left or to the right. So adding that c translates it, I said that wrong, to up or down. Okay, left and right is horizontal, it translates it up or down. That's vertically. Sorry for my misspeak there. When there is no linear term, there's no bx term, the axis of symmetry is the y-axis. Let's take a look at this graph. G of x equals negative 3x squared plus 4. So we can gather some information from this before we even plug in any numbers. We see that it has a negative a term, which means our parabola will be opening downward. And our constant term is 4, which means it's going to be translated 4 units. There's also no bx term in there. And if you remember what we said, when there's no bx, when there's no linear term, the axis of symmetry is the y-axis. So it's going to be right on the y-axis as our axis of symmetry. Our vertex then would be 0, 4. Since the parabola is on the y-axis, so the x value at that point is 0, and it's translated up 4 units. So that is our vertex. The graph does open downward, like we said, because of that negative 3, and the vertex is going to be our maximum point, because a equals negative 3. So we can already guess that our parabola would look something like this. Okay, if this were 0, 4, that's my xy axis there. Our graph, very roughly drawn, is going to look something like that. The domain is all real numbers, and our range, since our graph is opening downward, our range must be less than the vertex, so y must be less than or equal to 4. Now, the graph is going to be steeper than our parent function because we're multiplying it by 3. That makes our slope there steeper, so it's going to appear that the parabola is narrower or more squished, if you will. We can make a table for the function using at least 5 values for x near the vertex, which we know is 0, 4, and connect our dots to graph that function. As you can see, we've plugged in these 5 points, and this is steeper than our parent function of y equals x squared. It is opening downward, and you can see that the y-axis is our axis of symmetry because there is no bx term. No bx term means it's going to stay right on the y-axis. All right, so you guys today learn how to graph quadratic functions. You can use a chart to plug in your x values to determine the y coordinate that goes with that x. And we also determined the domain and range and vertex and line of symmetry for all of our quadratic functions. If you have any questions, be sure you write those down and ask me next class.